Every time you use Google Maps, check weather forecast or see flooding on the news. Remember, GIS is working behind the scene. In the next 18 minutes, I'm going to show you exactly what GIS is, how it works, and why it's one of the most powerful skills you can learn today. Whether you're a student or a researcher, or just someone curious about maps, stay tuned for the next 18 minutes. Today's meeting is just about the introduction to GIS. So we all know what GIS is about. I'm just assuming that we all know what GIS is about. So this tutorial is basically just trying more light on GIS. We won't go deep the intent of GIS. And as we all know, in everything we do, we need the fundamentals. So we need to learn something small about the fundamentals, then we can move on to the practicals. So one may ask why this training? Basically, this training is organized by the Geospatial Learning Hub, and what we do is we try to educate people on geospatial analysis. So as geospatial is concerned, anything under geospatial, do not hesitate to reach out to us. So who am I? As I said earlier, my name is Gabriel Tete, and then I graduated from the University of Cape Coast. So this is just some small information about me. So those of us on LinkedIn, that's my LinkedIn profile. Should in case you want to reach out, you can just connect me on LinkedIn. Then whatever it is, we can communicate. We are also open to business. So assuming you want anything to be done for you, as far as geospatial is concerned, do not hesitate to reach out to us. You will be said. Okay, so let's dive into why we are here. So as I said earlier, the objectives for today is understanding what GIS is and what it can be used for. And I'm assuming most of us here, we know what GIS is. The GIS we are seeing here is just an abbreviation. So the full meaning of GIS is Geographic Information System. Geographic Information System, which can be broken down into two smaller parts. So the geospatial here, or the geographic, means space. That is something that can be located in space. And the information system is basically about computer assisted system that is solely meant for capture, analyzing, transforming, and disseminating information. So as I said earlier, geographic means what? Space or spatial. Then the information system is about the organized combination of computer hardware. So the hardware here is your laptop, whether you are using a laptop, whether you are using a mobile phone, whether you are using a desktop computer, that becomes your hardware. Then the software has to do with the various GIS softwares, as in the ArcMap, ArcGIS Pro. Even though now ArcMap has been retired, so we do not have ArcMap in the system anymore, even though you can still download and use it, but recognizably it has been retired. So we have ArcGIS Pro, QGIS, and other GIS software tools like the Idrisi, we have EDAS, Imagine, among others, solely for the purpose of collecting. So we all know collecting means what? You are trying to capture something. So the collecting here is basically about you using a GPS system. You can use your mobile phone to capture data, then transform it. The process of you transferring that data you've captured from the GPS device to your software is what you are transforming. Managing, that is where you do your analysis, then disseminating information to the channels within which you can present the findings. That is meant by disseminating information. Then as I said earlier, that GIS is purposely meant for capturing, visualizing, and disseminating information. What are we capturing? What you are capturing here is called what? Geographic entity. So a geographic entity is just a real world thing that can be represented in the GIS world. So assuming you are trying to capture your house and represent it on your GIS software using your hardware, which is your computer or your laptop, your house here becomes a geographic entity. And as you know, before you can represent something in space or before you can represent something on your GIS world, that particular thing must have three attributes. Just like when someone says, okay, all knowing, we all know that the person is referring to what? God. Omnipotent, we know that the person is referring to God. So that also implies to geographic entity. Every geographic entity must have spatial attributes. The spatial attribute here answers the question where, as in where is the thing is located. So your house, where is your house located? Okay, my house is located in, let's say, Abu Abu or Amamoma. That becomes your spatial attribute. So the spatial attribute describes the location and shape of the entity on the Earth's surface. So an example is a school at latitude 5.1 degrees, either north, blah, blah, blah. Then we also have thematic attribute. So the thematic attribute here is about the description, so the characteristics of the thing. Assuming we are using a school, the spatial attribute becomes the location of the school. The descriptive attribute or thematic attribute becomes the function of the school or the characteristics. Okay, this is a mixed school or it's just a single cell school. Then the last attribute of a geographic entity is temporal attribute. The temporal attribute has to do with when. So every geographic entity must answer three questions: where, what, when. Your where becomes the location. Your what becomes the descriptive attributes, as in the characteristics. Then the temporal becomes the time frame within which that particular geographic entity was captured. So temporal attributes describe the time aspect of an entity. So that, okay, this in mind that every geographic entity must have three attributes: the spatial attribute, as in where; the thematic attribute, as in what; the temporal attribute, as in when. So any entity which does not bear any of these characteristics does not qualify to be a geographic entity, because there is no way you can represent your house using a GIS software without the spatial attributes of your house. You definitely need the location. If not the description, you need the temporal as well. If not the temporal, you need the spatial attributes. So an example is an example of geographic entity is you thinking of a hospital. The spatial attribute becomes its coordinate on the map. And coordinates here is just a spatial reference that help us to locate or represent a spatial attribute in the GIS world. So they are just reference numbers. Then the thematic or descriptive attribute becomes its original hospital. That means you're trying to describe the hospital as an entity with 300 staff and it has 500 beds. Then the temporal attribute becomes the date within which the data was updated. So data was last updated in July 2023. So as said earlier, GIS is a computer assisted system solely for the capturing, storage, retrieval, analysis, and display of spatial data within a particular organization. But then there are some components of Geographic Information System, and these components include data, software, methods, hardware, then the people involved. So the data here becomes the backbone of the GIS software. GIS is nothing without data. If you don't have data, ask yourself, what are you visualizing for your audience? Then you also have the software. So the software here becomes the either ArcMap, ArcGIS Pro, or the QGIS software you are using. Then you have the methods. So the methods involve you the step by step that you use in running any analysis. So an example can be the step by step used in digitizing any GIS or data. So assuming you are being provided with satellite imagery to capture some geographic entities on it, the process you took the process you took to finish your digitizing becomes the methods. And the people here becomes you and I, as in the trained personnel who have been trained to use GIS. And mind you, GIS is nothing when people cannot use it. So GIS data, as in the heart of GIS, and GIS is nothing without data. So what is data on its own? A data is a geographic information that is viewed and analyzed using the computer hardware. So you see, it's more like they are interconnected. One is nothing without the other. Even though these days we have some cloud processing GIS software like the web GIS, where you don't need uh, the hardware, but you still need the hardware because it's a web something. And before you can go into the web, you need your computer hardware. So you see, they work hand in hand. One is nothing without the other. And we have the people, as in the users. GIS is only useful when people know how to use it. And the methods or procedure. The methods or procedure are the step-by-step approaches or ways used to collect, store, analyze, and visualize the GIS data. So as I said earlier, an example is describing how to digitize a map or how to classify a satellite image. So as I made mention of that, every geographic entity must have three attributes. So that geographic entity becomes your geographic data. So that data must have a spatial attribute, a thematic attribute, and a temporal attribute. So these are the components of their hardware, the software, the data, the people, and the methods involved. Okay, so functions of GIS. GIS is a computer system that help us in one, data capture and processing. Thank you. So functions of GIS. GIS is mainly used for data capturing and data preparation. So once you capture your data, the next thing is to prepare your data. Then you store that data, you maintain that data, then manipulation and analysis. You can store the data, then straightforward, it can lead to data presentation. So therefore, GIS is mainly or purposely used for these four things, as in data capturing, data storage, data analysis, and data presentation. So what are the purpose of GIS? GIS is used to identify geographic phenomena, to explore a geographic phenomenon, to describe, analyze, examine, predict, simulate, and assess a geographic phenomenon. Okay, so these are some applications of GIS. But as of today, if you ask me where can GIS be applied, I'll tell you everywhere. GIS can be applied everywhere. I know it might be ringing in your head. Okay, so me being a farmer, how can I apply GIS? And then we have an analysis called suitability analysis, whereby assuming you are a maize farm. So this suitability analysis can help you identify places on your land that is mostly what's suitable for maize crop. So GIS is basically applied everywhere, irrespective of the profession you find yourself. You can apply GIS there. So we have simulate and spatial pattern of diseases, estimation of urban flood risk, assessing of carbon emission from wildfires, predicting weather patterns, and land use land cover or land use planning. Basically, GIS can be applied everywhere. These are just some 6 options that I brought here. But if you ask me, where can I apply GIS? I'll just tell you everywhere, irrespective of what you do, you can apply GIS. So these are additional applications of GIS. And GIS can also be applied in our daily research, as in the identification of problems. So let's assume that, let's use Accra as an example. With a problem of flood, we all know that during the rainy season, each and every year, Accra always gets floods. So your problem here becomes flood. Formulating of hypotheses and research questions. What are the causes of the flood? Then you have data collection. So this is whereby you can use any GIS or any GPS supported system to capture data. You can also use satellite imagery, as in the past and present, to analyze the flood issue. We also have the analysis. This is whereby you can use the GIS software itself to come up with analysis. Then you have the presentation. So you can use either dashboard, WebGIS to present your finding. Then you are good to go. Okay, so as I said at the beginning, GIS is nothing without data, and data is also nothing without GIS. And in the GIS world, there are basically 3 types of data models that we usually use, but only 2 of them are common. We have the vector data, raster data, then the team data. The team data is not common because it's mostly generated after processing a LiDAR data. And the vector data and raster data, they are the most common ones. So a raster data set comes in a form of smaller boxes, but they are not just boxes. They are interconnected pixels that connect digital numbers and visualize it as a continuous surface. Then you have the vector data. The vector data is made up of the line, points, and polygon. So let's dive into the data models. So the nature of a geographic data. Every geographic data must have spatial components. And if you do remember, in my earlier presentation, I said that every geographic entity must have a spatial attribute. And you all know that a geographic entity becomes a geographic data. So the spatial component here involves the geometry, as in the dimension, the shape of the entity you are capturing, the coordinate system, as in the location. So you see, data here is nothing without the coordinate system. Then the spatial relationship, as in the topology. Where does it share its boundary with any, or does it share its boundary with other spatial entities? Then you have the descriptive attribute, as in the characteristics of the object. So this is describe the spatial object. Okay, you are capturing a house. What is the descriptive component of that house? As in, it's, let's see, a residential area, and it has about 26 households. Then you have the time component, as I said earlier. The time component has to do with the temporal element, which shows the time frame within which the geographic data was captured. So these are the various types of geographic data. One of the most important functions of GIS is its ability to handle different types or different kinds of spatial data. Therefore, what is a GIS data? Data is a fan of every GIS. Without data, GIS is nothing, because there will be nothing for you to visualize, analyze, and interpret. Therefore, data refers to the objective measurement of attributes, as in the characteristics of the entity you are visualizing, or the information which you want to visualize using your GIS software. These are the various data types, as in the descriptive attribute and the location attribute. So sources of GIS data. GIS data can be captured from existing data, and we can also acquire a GIS data. So an existing data source becomes a secondary data, whereby the acquired data become a primary data. So the existing data, we can get an existing data from digital maps, paper files, and other sources. And acquisition can be in a form of remote sensing, as in you trying to get information about something without being in contact with the thing. And we have photogrammetry. So the photogrammetry is whereby you see that cameras are being placed on aircraft to capture a specific area. Then you have the field survey, whereby you go to the field, you use your survey tools to capture geographic data, and you are good to go. Then, so now that we know that we have three kinds of geographic data, as in the vector data, raster data, then a thin data. What then is a vector data? Data is one of the common type of GIS data, and it comes in the form of points, lines, and polygon. The points are used to capture what features that can be represented in your GIS world by a single location. An example is a tree. Assuming you want to visualize the tree that is within your localities, there is no way you can use a polygon to represent a tree. There is no way you can use a line to represent a tree. You can only use points to represent a tree. Your house on its own can be represented based on points, can be represented using points based on the context within which you are presenting your house. So an example of geographic entities that can be represented using points involve towns, cities, trees, and others. Then we have the line. So the line can be used to represent linear features. An example is a road or a river body. There is no way you can use point to represent a road, but mind you, you can use a polygon to represent a road. You can also use a polygon to represent a river. Depending on the context, then you have the polygon. So polygon are used to represent geographic entities that have boundaries. An example is your house, the boundary of Ghana, the boundary of your community. You can also use the polygon to represent the various districts in Ghana. So this is an example of the representation of vector data. So you see that the points here are used to represent some communities within Ghana. And the second one, which is this one, this is a line feature which is representing the various water bodies in Ghana. Then we have the administrative boundary of Ghana, which is being represented in a polygon format. Then we have some file formats for vector data. So once you see KML, which is Keyhole Markup Language, which is suitable for Google Earth, it automatically becomes a vector data. But then that vector data can either be in point, line, or polygon. So these are some file formats of spatial data or spatial vector data. So whenever you see any file format like this, should it should remind you of a vector data. And one of the most common vector data file formats used in the GIS world is the vector data and shade file rather, sorry. So whenever you see a file format like Ghana.shp, the shp there means shade file, and that is the most common vector data file format that is being used in the GIS world. We have other file formats like MDB, GeoJSON, GPX, and others. But the most common one is the shapefile.shp. Then we have raster data model. Raster data is used to represent features as a continuous surface. So an example of a raster data is a satellite imagery, and each raster data is made up of a series of boxes. Just take into consideration a picture you captured using your mobile phone. You see, whenever you're trying to zoom into the picture, it gets to an extent whereby you see that it's made up of series of boxes. Those boxes are called pixels. And behind those boxes are numbers. Those numbers are called digital numbers. So once those numbers are being processed and visualized in the GIS world, it automatically becomes a raster data, which is being presented in a continuous surface. So an example is a satellite image, aerial photographs, digital elevation model, and each cell presents a value, such as elevation. So that particular box you are seeing, there is a number behind it, and that number can be either elevation, temperature, the slope figure, among others. So you should take this in mind that raster data is made up of series of pixels, and each pixel contains a number, and that number is called a digital number. Once the digital number is being processed, it is automatically visualized as a continuous surface in the GIS world. So once vector data is made up of line, points, and polygon, raster data is made up of pixels. Then there comes the thing data. It's not common. The thing data is made up of series of triangles, and behind those triangles, it contains numbers as well. So this is a raster data model. You see there is a small point here which is showing points. Then we have the line and the polygon as well. Characteristics of a raster data. So things you should keep at the back of your mind whenever you see a data file format which is represented as a raster data. One, it contains cells. So you see this. These are the cells. These smaller boxes are cells, and each cell contains a number. So you see, it's organized in rows and columns. Single value per cell. That means each cell hold one value, representing data like color, temperature, or the vegetation type. And it's what represents as a continuous interface, so a continuous coverage. Just look at this example. You see that it is rows and columns, and each row is made up of smaller boxes. And behind those smaller boxes are the numbers I'm talking about. And once they are joined together, it automatically becomes a continuous interface. So this is an example of a raster data file format or a raster data. You see that it's being represented in a series of boxes. So this is more like an elevation data. It can be a data set that is depicting the temperature of a particular place. You see that it's being presented in smaller boxes. Assuming this data set has been zoomed out, you automatically see it as a flat or a continuous interface. So each box like this, each smaller box contains a digital number, and we have a way of showing that number using the identification tool in the GIS software. So once we get into the practicals, I will try and visualize one of the numbers behind. So this is an example, another example of a raster data. This is a satellite image. You can see that it contains some farmlands. But once you zoom in, you see that they are made up of boxes. So the first one has been zoomed out or been zoomed in, and this has been zoomed out. So you see the differences. You see these are smaller boxes. But then you see these are the boundaries of some fields or cultivated areas. Okay, as being mentioned earlier, GIS is nothing when people cannot use it. GIS is nothing without data. But mind you, as a data set or a data becomes the backbone of GIS, coordinate system also becomes or is the backbone of a data. Without the coordinate system, your data is nothing. I remember trying visualizing or I captured the data, trying to visualize it, and my data was in the sea. Meanwhile, I've not been to the sea. That issue has to do with coordinate system. So there is no way you can visualize a data in the GIS world without a coordinate system. Yeah, I know you'll be like, but I can visualize the data and later on the system will tell me that it does not have any spatial reference system. Sometimes when you try to insert a big map which will serve as a reference, you could see that your data is somewhere and the location you are trying to visualize is also somewhere.